Now that we can control the starting position of our player by taking the current position and assigning it new positions, let's go ahead and figure out how we can move our character across the screen. So as you can see right now, I'm doing this through the transform component, or I'm sorry, the translate tool, which is affecting the transform component, specifically the position along the X. And if I do the same thing on the Y, it moves us along the Y axis. Okay? What I'm doing right now is I'm translating the object in the scene. Now, it's similar to how we adjusted the position by doing transform.position. There are methods that allow us to affect the transform in other ways, such as movement. So what I want to do is I want to head on over to the scripting API for the transform method. So open up the Unity manual, and I want to head back over. I want to look at the scripting API for the transform component. I want to see all the manipulations that we can do related to the transform. So here you can see the description for the transform is the position, rotation, and scale of an object. All right? And what's important to understand here is that every game object has a transform, and every transform is a game object. You can pretty much use those terms interchangeably, and you can always access anything about an object from its transform. For example, before when we were printing out the name of our player, or whoever had this script attached, we just wrote name. What I could have done as well is I could have said transform.name. Transform gives me the root axis of the object, and then from there I can get whatever I want off that object. So what I want to do is I want to figure out how can I translate our object. So looking at the scripting reference here, we have different variables that we can get from our transform, and then we have different methods here, or functions, which are also used interchangeably. There's no difference between functions or methods. It just depends on the programming language you're working with on how they refer to them. So what we want to look for here is a method that's going to allow us to move our character. And like I said, what we were currently doing in the scene was translating our object. And if you look here, there is a translate method attached to the transform component. Moves the transform in the direction and distance of translation. Let's go ahead and check this out. Here's the example for this. It says moves the transform in the direction and distance of translation. If relative to is left out or set to space.self, the movement is applied relative to the transform's local axes, the X and Y and Z axes shown when selecting the object inside the scene view. Okay, so how do they implement this? They type in update transform.translate, and then they open up a parenthesis and they say vector3.forward, and then multiplied by some other stuff. Now, oftentimes it might be confusing to follow along with the scripting reference. So what I highly recommend you do is when you're looking at the scripting reference, just grab the syntax and let's use our tooltip and let's break it down and follow it step by step. So let's head on over to Unity, because now that we know that we can move an object using translate, let's go ahead and try it. So here, we're going to grab hold of our object using transform, and then we want to move our object using translate. We'll open up a parenthesis, and you're going to say here, vector3 translation moves the transform in the direction and distance of translation. What I can pass in here is a vector3. So let's go ahead and say vector3.write. And let's go ahead and save this. Head back into Unity and go ahead and play this. Right now, we told the object to move to the right, and you'll see that it flew off the map. And if you actually look in the inspector, the position is constantly moving very quickly to the right. Now, you might be wondering, why didn't I have to use the new vector3 keyword? Well, that's because Unity provides a default vector3.write. If I wanted to, I could also type new vector3. I want to move along the x-axis 1 unit, and I want to stay where I am on the y, and I want to stay where I am on the z. Let's go ahead and save this. And you'll see we'll get the same exact effect. Now, the question is, why are we moving so quickly? Well, that becomes a problem with moving per frame. So remember, the update method is called 1 time per frame, and the typical PC runs at 60 frames per second. So technically what's happening here is we're telling the game to move 60 meters per second. That's insanely quick. What we want to do is move 1 meter per second. So how can we incorporate real time into this? What we can do, and I'm going to change this back to vector3.write, is we can slow it down from frame rate to meters per second by adding in real time. vector3.right. And what we're going to do is we're going to take the vector3.right and we're going to multiply that by time.delta time. And what this is going to do is this is going to smooth out our frame so that essentially, instead of moving 60 frames or 60 meters per second, we're now moving 1 meter per second. So if we go ahead and save that, let's go ahead and run this. And you'll see now we're moving extremely slow. Now we're moving 1 meter per second versus 60 meters per second. Now how can we go ahead and speed this up a bit? Because essentially we're going to want to have some sort of speed to our character, right? So right now we're moving 1 meter per second. Let's go ahead and make it so we move about 5 meters per second. It's simple. We're going to multiply it by 5. We'll go ahead and save. And now we're moving 5 meters per second. And there you go. So now that we're moving 5 meters per second, what if we wanted to adjust this in real time? For instance, every time I want to change the speed, like what if I'm not happy with 5 meters per second? What if I want it to be maybe 20 meters per second? Do I need to constantly come back into this code and always update this value, save it, and then go ahead and check it out? No. This is where we're going to introduce variables. Variables are like boxes that hold information. For instance, we can create a speed variable that holds the value 5. And what we can do is we can change that speed variable. And whenever that variable is used, it will take whatever the current value is assigned to it. So when declaring a variable, there are 3 required components with an optional 4th. The first thing is a public or private identifier. Is this variable going to be public or private? If it's a public variable, it means anyone can access this variable. You can access it from other scripts, which we'll get into later in this section. If it's private, then only this script, the player, has access to this variable. So what we're going to do here is we have a public or private identifier. Then we have a data type. All right, so every variable has a data type, which basically is what is this variable going to hold? The most common data types are ints, which are whole numbers, floats, which are decimals, booleans, which B-O-O-L in C#, which are true or false values, and then we have strings, which are characters of text. So what we're going to be doing here is we're going to create a speed variable. And the last required component is every variable has a name. The 4th component to this is an optional, and you can assign it a value. Optional value assigned. So let's look at declaring a speed variable, and we'll go ahead and make it public, and I'll show you the difference between a public variable and a private variable. So we're going to type public, our identifier, public or private identifier. The data type, it's our speed. So we might want to make our speed 3.3 meters per second. So it's going to be float. Every variable has a name. We'll go ahead and name it speed. And then we can optionally assign it to say 5.0. Now, this isn't going to work if we just save this. Because it's a float and I'm using a decimal, I have to include a F suffix at the end. That specifies that I am using a decimal value. So here I've created a variable called speed, and to use this variable, we're going to replace this hard-coded 20 and put my variable name there. So currently, speed is 5. If I wanted to, when the game starts, I can go ahead and set speed equal to 10. And now, when this gets ran, speed will equal 10 because we changed the value of speed. So let's head back into Unity. And the benefit of making variables public is that we can actually see them in the inspector and we can change them in real time. So right now it's 5. And as soon as I hit start, because void start is active, it changes to 10 because we told it to. We reassign the value of speed to 10. So I'm going to remove that 10 here. I'm going to remove this part where we reassign it. Let's go ahead and save this. We have our speed value set to 5. And now what I can do is I can go ahead and change this to say, I don't know, let's go ahead and make it a -1 and see what happens. And now what should happen is we should move to the left. And there you go. Negative values will move us to the left. Positive values, and I can change this in real time, which is awesome. As you can see, we're going right. I can change this value in real time and it takes effect. And if I set this to 0, we're going to stop moving. Now, I'll explain the math of this in just a moment, but what's also great to notice here is we started this game with a value of 5, and I'm going to go ahead and say I'm happy with a value of 10. If I stop playing, nothing has saved, and it goes back to the initial value. That's so important to remember that when you're in play mode, any changes you make to your hierarchy view and your game view or your scene view, nothing will save. So as soon as you stop playing, all your changes are going to revert back. I can't tell you how many times when I was starting out that I was literally developing the entire game while the engine was running. And as soon as I stopped playing, all that work was gone. So you definitely want to make sure you're not in play mode while you're making massive edits. However, for information like this, where I can use play mode to get real-time results, it's an excellent tool for rapid prototyping. So, how does this math work? Why is it that when the number's positive, we move to the right, when it's negative, we move to the left, and when it's 0, we stay still? Well, this comes back down to an old elementary middle school math subject you guys may remember called the FOIL method. The FOIL method is something you probably learned in your basic algebra class, and essentially what it is an operation that tells us to move right or left based on whatever this vector value is. So here's what's essentially happening here. Check this out. We do transform.translate, and then we have vector3.write. If we actually convert that vector3.write into what it typically would look like, which is the new vector3 with the 1, 0, 0, what this is reading is that we're moving 1 unit along the x-axis. If I wanted to move left, I could simply say -1. Now we're moving -1 units on the x-axis. So say we keep that at 1, right? Because that's what vector3.write is. Then what we're doing is we're multiplying it by real time, which essentially time.delta time, you could say, could have a value as 1. And then we're multiplying it by our speed, which would be 5. So using order of operations, what's happening here? This is happening first. 1 times 5 is 5. All right? And then what we're doing here is the FOIL method. 1 times 5 becomes 5. 0 times 5 is 0, and 0 times 5 is 0. So anything multiplied by 0 is always going to be 0. But what's happened now is we're moving to the right 5 units. So what happens when my speed is a -5? Well, now what's happened, and if I set this back to a vector3.write, now what's happening is you have 1 times -5, which is -5, and -5 times 1 is -5. So now we're moving to the left 5 units. Now what happens when speed is 0? Well, this is set to 1, and anything multiplied by 0 is going to be 0, so 1 times 0 is 0, and then here, 1 times 0 is 0, 0 times 0 is going to still be 0, and same for the z. That's how that math is working and controlling what this vector becomes. This vector is going to become either a -5 to go left, a 0 to stay still, or a +5 to move right. Now, that's as much math as we're probably going to cover throughout this entire course. You don't need to be an expert at math to become a game developer, but it does help if you have a basic understanding of how some of these things work underneath the hood. So what we're going to be doing in the next section, guys, is we're going to look at user input and how we can use that to determine what the value of this vector should be. I'll see you again.